Welcome everyone to this week's IPLD sync meeting. It's March the 28th, 2022, and as every 2 weeks, we go over the stuff that people have worked on and then discuss any open agenda items or if anyone has anything to share. So I have to look at the meeting notes because today I don't have anything to share. Oh, and then if you attend, please add your name to the attendees list. I first name in the list is Mauve. So please share with us your news.
Yeah, hi. Last week was kind of busy for me with other things, so nothing super exciting. But I've been working some more on the IPLD URI spec. So Eric and I met the week before, and we did a whole bunch of drafting and writing a whole bunch of potential specs and like what we wanted and didn't want. And it turned out to be really huge. So last week I was sitting down and kind of thinking, there's a way to like pare it down to just like the minimum viable spec without lenses and ADLs and advanced traversal. So right now I'm putting together something in in an exploration report, and hopefully I'll have something out there for people to look at. We still have some time in the Agrigore mobile dev grant that we're working on to maybe even put together an implementation to try it out for developers to use. So I'm pretty excited to see how that goes. As well, we got together to look at the checklist for IPLD implementers, and we did a whole bunch of restructuring. So now there's a lot of to-do items and new sections that weren't there before. Also, we're working on updating the what is IPLD image in the docs. So Eric put together an awesome diagram that's on a whiteboard and kind of like gives this grand vision on how different pieces fit together. So right now we need to figure out how to make the data in the old image still visible in the page. And also there is a design shop request open that is processing to make like an actually clean non-whiteboard version. Also for the agenda, I wanted to just bring up some thoughts I had about setting up a GitHub team so that people can reviewers in a PR, because right now it's a little unclear as to who should be reviewing what and where. And it seems the default seems to be to @warpfork, but I think he's already got a lot on his plate. So I don't know if that's something we discuss now or after everyone else does updates.
We can also quickly discuss this. I guess there's not that much to discuss. I guess the question is who creates this group, and then
we do have them already. Can we just reuse the ones we've already got? I think we've got IPLD Go team and IPLD JS team or something like that.
Let me see.
Oh, okay. Oh, yeah. So can I just add those? Okay, yeah. This should actually work. All right. Then I think we just go ahead with the updates and then we can get back to it later. So next on my list is Daniel.
Cool. So this past week hasn't been super productive for me, so I'm mostly going to cover what I did 2 weeks ago. So I wrapped up the fuzzing of IPLD Prime, meaning mostly Binode and Daxibor for GraphSync. Couldn't find any more bugs in the parts that we care about, which is the schema and Binode packages. We did run into some more Daxibor, you could call them bugs, but it's essentially that I wrote the fuzzer as per the spec, meaning, I expected the codec to require canonical encoding. But we don't actually require that on the decode side, which is fine. It's just that the specs maybe need to be reworded a bit to be clear. And I wrote, so there's multiple ways in which the decoder is lax. So there's integers, there's floats, there's map orders, there's a bunch of things. And I think with Eric and others, we came to the agreement that instead of having one knob for each one of them, we should just have one knob that's opt-in and says be strict, because we want to keep the default what it is right now. So I've linked the two PRs that work towards that. I'm not finished yet. I also have, at the top of my to-do list, I started doing this, but I haven't finished it, is allowing nillable types in Go as optional / nullable with bind node, meaning that in an IPLD schema, if you have, for example, a field that's optional or nullable, right now bind node wants you to use a pointer, which is fine, but sometimes you end up with like a pointer to interface. And then you can end up with, nil or non-nil pointing to nil, or like those kind of weird states. So I just want to allow it to work with nils directly if it's already an option. So it's not rocket science in terms of reflection, but I want to add enough test cases, which is why this is still a work in progress. Also a bunch of code reviews. I think I've unblocked both Will and Eric, but please let me know if I have missed something. And an FYI to Rod, I'll be in South Korea in 2 weeks, unless I test positive again at the airport. But hopefully we can get a few days of working closer together without the time zone shenanigans. That's it for me.
Thanks. Next one is Rod.
Right, I've been out sick. I've got proper sick, and just really coming back on board now. The only thing I've got in the notes is just something that pull request from Ghazala on JSCar that I thought would be interesting. They've got a use case for cars in the dot storage world, where they really are using it as a transport to throw blocks around, and so they're doing smallish cars to bundle blocks to send places. And the whole infrastructure of create a car, write it to a thing, and then have to go back and redo the routes and all that sort of, like, it just gets in the way, and you've got to write it to somewhere. It's just a hassle. So he made a buffered writer where you the main interface to it is you basically give an estimate of how big the car is going to be. It will, at least the header is going to be. So you can say how many routes you're going to put in it, and it'll pre-allocate, and then it'll actually, no, you give an estimate of the whole lot, and it'll pre-allocate and then just write into this thing and then give you back just a slice of it that it needed. So that's a neat little feature. That just gives them the ability, a really simple interface to just sort of create this thing, write into it, and then be able to send it off. So I just thought somebody might be interested in that. So a PR 70 on JSCar. That's it for me. Will?
Sure. I just have a couple sort of small side things or continuing. There's a PR up that Dan took a look at that adds a reification function to the Filecoin HAMT data structure so that it can be used as a ADL. So in the same way that we use UnixFS for being an ADL, we could take this HAMT and use it as an ADL, so that if you, for instance, are trying to pull part of the Filecoin chain, you can now directly ask for like the map key of like, I want the miner with this ID. And even though that's actually, a multi-layer HAMT data structure, you don't need to know exactly how it's laid out when you make that ask. So that has some uses in recovering specific queries as that Filecoin chain history gets backed up onto Filecoin itself, and you now want to retrieve it without knowing it in advance. So thanks for the review, Dan. I think there's still going to be probably we need to get the like that code while it is in a Filecoin project, and I think it is maintained by initially spec actors, and I need to figure out who the current like owners of that code are to make sure they're cool with that. In addition to us on the IPLD side being cool with it, and then once we are all cool with it, we can add it to some of these ADL maps or registries. I probably also have another. Oh, go for it, Steve.
Yeah, real quick. Well, is this? I mean, this is very cool. Is it blocking anything for you?
No, it is not critical.
Okay, no, just wanted to be aware. But yeah, and I'm pretty sure Wyatt, it would be like the current owner. I don't know if Alex wants to jump in, but I would probably engage with Wyatt on it.
Rock on. That's right.
Yeah, in terms of spec actors, it's Wyatt, but in terms of reviewing other pull requests, it's been largely Stephen and me functionality stuff. But I think you're hitting up issues there with Alex. I think he seemed to have the biggest objections to the amount.
But that was a long time ago. That was on the initial draft, like when I was using it for state diff like a year ago. So I think what is there now is different in substance from what the initial state of that PR was. So I would not look at the first round of comments on that PR because that was essentially a different PR at that point. And then there was a question on how to resolve the IPLD PIME extension to traversals for resumption. And I'm most of the way through taking that and putting it into GoCar so that GoCar can use it, because GoCar was really the only consumer that I had. I can just make it an interface there. It doesn't need to be in IPLD Prime. So I expect the PR in IPLD Prime to go away, and it'll just get folded into the partial resumption in GoCar. Cool.
All right, next one is Eric.
I do not have a highly populated list of stuff this week. It's been a chaotic time. One thing that does seem worth a brief mention is folks in the chat had brought up the use of CIDs as map keys. And I've written up a little bit of an issue to discuss that. This is something that, long story short, people do recurringly want. It is obviously a good idea and makes total sense. And yet it's a little bit tricky to pin down exactly how it should behave, because you end up in the juxtaposition of, well, this isn't a string, and by the way, DAG.json exists. And so one needs to navigate carefully in that vicinity and figure out how indeed will we make it fit together. So detailed though that is, there is now an issue with details. So if anybody would like to sink their teeth into that and see if that reasoning works for them, if they can put that to use already, or if they have other ideas on how that should be pursued instead, there's a place for that discussion now. The other thing I'll mention in passing is, I can't remember if I slipped this in our last community call or not already. I put out a little bit of an exploration report for this concept of lenses. And this is a word that I might have thrown around historically. Why I'm bringing it up again now is this is a keyword that I'm introducing in this outline of a proposal to have a declarative syntax for specifying the use of any one of a series of lenses for doing data transformations. For example, this would rebrand ADLs as a lens and also rebrand schemas as a lens. This is cool for a couple of reasons, at least hypothetically, because it would give us a way to introduce other lensing systems extensively in the future, which is cool. But also it could be the foundation of a way to put this declarative description of where a lens should be applied into other protocols. So we've hacked this together for some special cases already, which totally works. For example, in selectors, there's a, I forgot what it's called. There's a clause that lets you say, please use an ADL here.
Interpret as.
Thank you. Which works perfectly and does what it says on the tin. But it was originally specified for ADLs. And so if we wanted to do something similar to that, but like say, please use a schema here, it would need more and different parameters. It would need a pointer to the schema, it would need the name of the start type, etc. And the interpret as clause is also specific to selectors. So what if we wanted to have some other protocols which also need to invoke lenses? For example, maybe we would have an IPLD patch protocol, which wants to say, please use this data transformation to navigate before you apply the patch, and also as you are doing the patch apply. And we wouldn't have a syntax for that yet. So this lenses proposal is a draft of such a syntax. Right now, it's just an exploration report form, so feedback is highly welcome. Maybe it'll turn into code eventually, but there is no current actual roadmap schedule for that. So just feedback phase. That's all I got.
Thank you. And next one is Dean.
Right. Hi. So I spent some time last week on this protocol that I have named Reframe for lack of other words. It is a response. It is a request response protocol, I guess, sort of framework. The idea is to basically have a request response protocol where you've defined the methods using IPLD schemas. And so they can sort of generically be, we can use DAG.json for all the things that like JSON. If somebody decides that they want to use a binary representation, they can use a different encoding. And we can use this to like move data around. The initial target of this thing is for routing requests. So all the things that one might expect the IPFS DHT to answer queries about. Who has my stuff? IPNS records, where is this peer, things like that are some of the initial methods we're targeting. If you have more things, you can add them there. This means that we've sort of been writing a bunch of schemas. Some of them have been pretty easy to write. Some of them have pushed into we'll call them schema boundaries. These things might be interesting to talk about. The two main ones were fallback conditions for unions, where sometimes you're like, I would like to have an empty space here for like, I haven't figured out, I don't know which keys, I don't know what, I have a map, they're keys, it's a keyed union. Some of these keys aren't defined yet, but like, I'd like to still move them around. And later on, someone can then, PR the schema with like a new, what does this new key do, right? And take it from there. And then the other is for having unions that aren't string based. This one's less critical. It's just like kind of awkward, where you're like, well, the identifier for this thing is really a number or something. But I guess all of our unions are strings. So do I guess I'll just encode the string as the number as a string or something, right? Which feels a little weird. It's not so dissimilar from like the I want CIDs as links thing, but it's like, as keys in that it explores this, like what can be the key part of the identifier field. But I suspect that whole thing is grosser for roughly similar reasons to why the how do I put the links as keys and maps is a little grosser. So thankfully that one's a less big deal. It'd be fun to talk about the fallbacks thing because I think that one might be an easy one. Also, I guess while we're reporting things we've done with IPLD that might be fun, I did some hacking on like a BitTorrent file ADL and a bencode codec. Mostly I sort of grabbed Will's code for Unix FS things and then was like, make simple. And it seems to mostly work. Once it does work, there will be a repo. It's brought up some interesting questions around like, when doing backwards compatibility with an existing thing, do you put the logic in codecs and have more codec things? Do you put the logic in ADLs? Do you split them? How do you split them? The way I chose for now was use like basic serialization, just like bencode, and then have all the BitTorrent stuff live in the ADL layer on top of the serialization thing. Yeah, and that's all for me.
Maybe they'll both be a lens.
Yeah. Oh, I guess I should answer Daniel's question. Or Pitar can answer Daniel's question, which is the relationship between Reframe and Edelweiss. I would say the difference, I guess, is one of these things is more targeted at like a specific or speccing out the wire protocols, right? So like the protocol has, or the spec that's posted there has, here's a list of schemas that we know about, and you might want to use these things, along with, here are some transports that we know about for how to move these blocks around, and here's how those transports work. So maybe this, you can call it like a particular instantiation of that, might be a way to think about it. Pitar, does that sound kind of right?
Yeah, I mean, I was gonna, if I get a slot, I can, I think nobody knows about Edelweiss, so I was gonna briefly mention it. But to answer this question, Edelweiss is basically a language and a compiler. So a language as in like a schema language, which is a superset of IPLD schema, and it's backwards compatible. But basically it's a new compiler that you can write schemas for a type system, just like IPLD schema. It has a bunch of new types that solve some problems that sort of come up with IPLD schema, like unions and singletons, meaning unions, not untagged unions, so structured unions. I can go in detail in a little bit. It also has other things. You can define services, and in general, the compiler framework is flexible so that it's easy to add new things, because we expect that Filecoin, for instance, actors are going to want to be able to send lambdas across network boundaries. So you want to have sort of types for these things, but at the same time be flexible about how are the lambdas encoded, because different chains have different ways of referring to a function instance. So basically all of these kind of problem domains are in the scope of this compiler. And so it's prepared to be a place where you can add more and more concepts. And the second part of the compiler is that it has a code generation framework, which makes it very easy to write generated code. Like the overhead compared to writing straight up Go code is like 10% or so. And so really it's a framework for basically playing around with schemas, adding all kinds of custom objects. And this framework is at Milestone One now, so it's like fully functional. And at this milestone, it supports, so it has the type system that basically is a superset of IPLD schema. It generates, and it also has definitions of services and methods, like similar to protocol buffers. It generates RPC services. You can plug whatever backends you want for the networking stack. So the first backend that we have is one that's going to be useful for the project that the Dean is talking about. But the connection between the compiler and the reframe API protocol that the Dean is talking about is that this API is described in the schema language, which currently is just an AST. So we don't have a syntax parsing, so you just sort of build an AST. So this protocol is defined, and then Edelweiss generates the entire, client, server, etc. That's the relationship. I guess since I'm talking, should I sort of continue on for a brief introduction and give links?
I would quickly solve this code owners code reviews question, because this is where we actually can use the sync time quickly, and then you go next. We should solve this like in 2 minutes. So as you see in the meeting notes, we already discussed it there, kind of. So yeah, I guess the question to Mauve is like, what's the intent? So basically that you get code reviewers, or do you want to ping people? So like it's kind of like two things, or do you want both?
Yeah, so this is mostly coming out of trying to submit PRs and review PRs and looking at stuff in the IPLD repos. It's not always obvious who should be pinged for what. So I think what was mentioned about having like a code owners file would be useful. For example, recently I submitted that PR with updating what is IPLD.jpg. And the question is like, who reviews that? Because I've been talking to Eric, but assuming Eric should review everything seems kind of rough and a lot of pressure on him. Or like, what happens if he's not around or on vacation? Who is the next person to reach out to? I don't know how much that applies to, like, say, specific Go IPFS or sorry, Go IPLD Prime repos or like language specific stuff. It feels like this is, I'm not sure if it's just the docs that need it or if other repos also have this concern. I think like looking at the chat or at the HackMD logs, there was some discussion about using teams, and also how teams might not be the right thing because you don't always want to ping the entire team. It feels like a reviewers group might be useful, but I don't know how fine-grained that should be.
Yeah, and we can, I mean, so your use case, whether you're submitting a code review into IPLD/IPLD, the doc site, or potentially into IPLD Go Prime, like you want to be able to mention someone or something and have it show up in someone's queue that like, hey, I need a review, right? And so we can certainly create additional teams for that, and so we don't have to marry the teams that are for access to the repos as the ones who are like our key code reviewers, maybe our key maintainers. So like, because I'm assuming there's really a handful of folks, most of the people on this call, that we like would want to be looking at some of these PRs. And so I would probably just create a team for for that case if we don't want to like be pinging the whole Go team or JavaScript team. I mean, we can even create a team that is IPLD and PL Endres maintainers. So it's not trying to say that this is like all the maintainers, but it's people on this call that are probably closer to the project, and at least that gets you more of the way there. But it's not trying to be exclusive that we are the the only maintainers of this work.
Yeah, or it feels like it's just the people that could like sign off and be like, okay, this is good to merge, are the ones that would be important to have reachable like that.
Wonder if it's worth leveraging, like if IPLD is trying this, like I don't know if it's the whole project or just Go IPLD Prime that's trying this like +1, +2 business. You could just take all the people that are the +1s or +2s and just put them in a list. That would also make it easier to track when someone should be added or removed from that list. If that's not something the whole project's doing and it's just for like the Go IPLD Prime repo, then forget it. But
could you elaborate a bit on what the +1, +2 thing is? Because I'm not aware of it.
Eric, you want to go?
Yeah, okay. Yeah, that's me. This still currently only resides in an issue in Go IPLD Prime for what it's worth. So no, it is not discoverable. My apologies. The proposal is that, yes, indeed, we do need to have more reviewers, and also we should like broaden that set a bit. And the arbitrary numbers there, the +1 and the +2 reference comes from the detail of the proposal of like, in order to merge most things, one should go for a total of a +2 sort of a score on it. And anyone who we understand to be like well-versed as a reviewer can give a +1. So if you get 2 independent people to do that, then you proceed. So that's a proposal that I kind of put out for how we could distribute this a bit more for the Go IPLD Prime repo in particular. We're kind of in the trying it out phase, see if that is the right size, if we can actually like internalize that mental model, and if it provides value or not. I wouldn't mind trying it more broadly too if it seems helpful. We did end up with a list of people for the Go IPLD Prime repo identified in that issue. We also didn't really have a huge discussion yet about how that list would evolve over time. So right now that list there is what Eric said that day. Honestly, capriciously. I might have forgotten people who should be on that list. I might have, yeah. So there's still work to do in developing that process more fully, I guess, is the long story short there. But if we want to try that, and if that list of names is any help, then great. Grab on to whatever you can, honestly.
Yeah, it feels like that list might be ideal for putting into a team and maybe having docs in the README about like, hey, if you're contributing, ping this group for reviews. I'd be down in also like helping figure that out for the IPLD/IPLD repo. since that's where I'm mostly working. I don't know if any of the other repos are interested in collaborating on that.
I guess in the past it has been that mostly everyone was subscribed to all repos anyway, due to the how we have the team managed. So I basically read all the notifications, but I guess it's depends on if people are if there's only one or two people, if they think oh, do I have the time to look into it? And then I would say basically the repos you are working on are the ones that got dropped the most, I would say. For example, if someone opens an Rust IPLD issue, on some Rust related stuff, I hop into it and figure it out. But on specs and docs, is often that it's at least I speak for myself, it's oh, hopefully someone else will reply. And then so I guess we should also get better at that.
So I guess just to kind of closing this out, a couple of thoughts. One is Pioch, who's a productivity engineer on PLNDRES, has been setting up so that all of our GitHub management is actually in GitHub itself. So we can actually create a PR saying, hey, create this new team and assign these people to it. It's all auditable. And once that gets approved, it'll all go create, Terraform behind the scenes creates the resources, etc. So that's a good way to discuss, is this the right set of people for the list? And then in the PR captures the discussion. I think what you're hearing here is there's a lot of it's kind of wide open for someone just to push to suggest something and get something across the line. And so if you don't mind doing that for IPLD/IPLD, that would be great. And my hope is that we could do that all in an issue /PR that ultimately gets merged and ratifies it. So what I'll do right now is just ask Pioch to get that set up for IPLD so that you can use it there. He set it up on some of the other organizations. He hasn't for IPLD yet, but at least that way we can have a concrete use case of doing this in the open and having it documented.
Yeah, I think that, the documentation sounds really appealing there, because after we go through the process once, we could say here's what we did and have that in that repo maybe even. So if someone else comes along and wants to add it to another repo, it would be obvious. It'd be cool to talk about how the Go IPLD Prime repo is doing it so far, so I can learn. I'll follow up on that async though.
Okay, so I assume we'll talk in IPLD dev. But thanks for driving on these things, and we want to get you unblocked and make this better for others. Thanks a lot, Mav.
Sweet, thank you very much.
All right, thanks. So I think now it's time for Peter.
Okay, so I'll just so I put the link to the project in the chat, and I'll just briefly, can I share my screen here? So I'll just briefly talk about it because we don't have time to go into details, but basically if you look at the repo, so first I've kind of made sure that all the documents are linked through the homepage, so you can just find everything. Essentially, this project is at Milestone One, so it's like fully functional if you want to write RPC services and just general IPLD schemas that you want to encode the code. You can, so the roadmap that you can click through is going to give you the bigger picture. So we completed Milestone One, which is described briefly here, and you can read here about basically the type system that we support and how it compares to IPLD schema itself. Roughly speaking, like I said, it's a superset of IPLD schema, and all the code for encoding and decoding is code generated, which means the following. So on the encoding path, the generated code should be faster than alternative options in IPLD schema because there's no reflection and there's no allocations. On the decoding path, I went for this milestone in order to get it done quickly. The decoders basically parse the data structures from pre-parsed IPLD data model, so they're probably going to be a little slower than alternative than bind node, although I haven't checked. But for Milestone 2, essentially, I plan to square these inefficiencies away, basically write code generation that natively implements node assembler for all the types. And when this is done, I expect that this is going to be faster than by an order of magnitude from the other alternatives, because it will be both no reflection and zero allocation, so it should be faster. So in the continuing in the roadmap here, you can read about how we plan to address here the variety of representations that IPLD schema has. So basically one of the kind of like the design goals, which after lots of conversations with people, I realized is like an important goal, is to basically be able to write schemas and be able to capture any pre-existing encodings. So there is this notion of transforms, which at least superficially sounds like what Eric was describing lenses are. But so this is coming in Milestone 2, and these transforms, because this is a compiler, all of these things are code generated. So transforms would be something that goes from IPLD data model to IPLD data model, and it's code generated and is aware of the types that are sort of at the end of the encoding or decoding chain, and there's something that you can chain and so forth. And then you can read in Milestone 3 is what I mentioned briefly, planning to add lambdas, which can have sort of customizable representation based on what system the lambda lives in, and so forth. So anyway, so this is, you can read the roadmap. The big wins in the existing Milestone 1 are essentially kind of coming from the union type. I will mention here, by the way, this is something that we can change, but IPLD schema sort of uses one word, union, for, I guess, tagged unions, and also it has this notion of kinded unions. But in sort of like the type systems of most modern languages, there's actually two different types. So what we call tagged union is actually called inductive types, which means that the type distinguishes different cases based on a tag. And so the cases can carry any value of any type. And this is what IPLD schema has. And then the word union means something that basically it is a collection of possible cases, and it doesn't itself have any footprint. It simply represents itself as the type that's the active case, and parses itself, tries to parse all the cases that it's aware of in sequence from the wire. So in the Edelweiss compiler, basically the type names are union for like the true union, which doesn't have tags, and inductive is for what is called a union in IPLD schema. So this type makes it possible to basically substitute. This type is very powerful, because the key goal of this is that when you have any kind of schema, if you want to evolve it, you can always substitute any element anywhere in a schema by a union of what its type used to be and new alternatives that you might want to be adding. So the key design goal here is that we don't want to like spend too much time perfecting schema designs, which to make them perfect for the future, because this never works. The idea is that no matter what schema you write, you're never backing yourself in a corner, because you can always kind of use the union type to like expand the schema at any point. So that's interesting. And then in the documentation, you're going to find, so Edelweiss for users is a deck of slides that basically covers all the types that are supported and everything you need to know. I have here a document about how they're represented on the wire. There's also a complete working example in the repo that you can build and run and look at the generated code. So that's the main, that's one more thing essentially that I want to say is you don't want to, I mean, first of all, it's a fully functioning sort of system at the moment, but the way I think about it is not just as like, you know, oh, this is like a fixed language for schemas. The key thing here is that there's a very sort of easy to use code generation system, and it's easy to, well, relatively easy because you're adding things to a compiler, but there's a compiler, a sort of pipeline, and it's easy to add new objects, like adding a service. The notion of a service is, you know, any new notion, really, any new type, anything is actually pretty straightforward. You basically add ASTs for it, and then you have a stage when you can sort of generate more ASTs from it, and then you have a separate stages for code generation. And the code generation framework is something like the Go template system, but it's much fancier because it understands symbols. So you can type pretty much straight up Go code and just have wildcards where you want to insert symbols, and then the code generation framework will like do all the importing and aliasing and so forth. This is like the stuff that's actually hard to do in practice. It'll do it for you, so you can pretty much be writing straight up Go code. So the bottom line is that it's a place that eventually, you know, should be self-serve to add new objects and so forth. Basically, that's the quick rundown. Okay. Yeah, and the delegated, I mean, the reframe API is it's documented in IPLD schema because people are familiar with the syntax of IPLD schema, and otherwise doesn't have a syntax. You know, we could eventually, when we have parsing, we could use the IPLD syntax itself. But yeah, so the reframe project is documented in the IPLD schema syntax, but it's actually implemented in Edelweiss, which we didn't use because presumably people are not familiar with Edelweiss, like AST language for defining types.
Also, to make it a little easier, so like if you want to implement a client for one of these things or a server and like, you know, JavaScript or Rust or whatever, that you're not necessarily like rebuilding, like I need to make the compiler output to my language. You just be like, well, I already have a bunch of this IPLD. I already have IPLD schemas and codecs and whatever lying around. So I should be able to get you know, a version of this going pretty quickly.
All right. Are there any questions, perhaps? I think I have a question because like the goals that I've wrote are pretty similar to what IPLD schemas are. Like, for example, like IPLD schemas where like from the beginning, like one of the goals was that you can just like evolve the schema. Like it's also like one of the major goals of IPLD schema. Or also like the code generation. So the code generation was like the first implemented, I can go at least, was first implemented, and then this like reflection kind of limitation. So it's like, sounds pretty similar to me.
Yeah, so I mean, so it does sound similar, but there's a few small differences which basically justify an entire new project, right? So let's see. So so code generation, IPLD schema doesn't actually have a framework for code generation, because I think the big point here is that using just Go templates is impossible to actually write a proper compiler with code generation, precisely because of like things like juggling symbols, where you define them, and so forth. So so the reason, I mean, long story short, like, and you know, Dan can correct me and so forth, but I think the reason bind node resorts to reflection is precisely because there's some things that are very awkward to code generate if you don't actually have a code generation framework, basically. So the other thing is so the other thing is like I wanted to decouple. So IPLD schema couples types with representations, and the reason, so we want to decouple them. And what does that mean? That means that like I can have one type, and I can have that type have multiple possible representations. And when I code generate, I want to be able to get one Go type for the type, and I want to be able to use it with different representation paths. Because, for instance, you might have one service which talks, you know, JSON over the wire with some other service and uses one representation for a specific struct, and then it talks CBOR and uses a different representation when it's, you know, talking to Filecoin or like saving things to a file. So basically, I might want to have a struct that uses the map representation on the one hand, and the list pair representation on the other hand. And so the current IPLD schema code generators don't have a way of doing this. You would get two separate objects. So that's what I mean by decoupling. The otherwise compiler will actually create one user type that represents the data itself with the transformation logic being other objects that you can at runtime sort of, you know, attach to the object and use the same struct type with different representation paths. So decoupling types and representations was one of the sort of things that was awkward.
Okay, I just have a question there, because like, but you then because of course then you would need to specify like when to use which representation.
You just get you get the representation as another object in Go that you can chain at runtime. Like basically the object that, this is the transforms that I was referring to, but these objects basically know how to, they implement node assembler and node, and you get them separately from the struct itself, and you can then say, I want to decode these objects by sort of chaining these two Go objects, by essentially chaining objects that implement node assembler and nodes for the two directions. So you get the separate objects, and in your code you can decide how to chain them together, basically, you know.
Okay, so if I would use two schemas, I could also use two schemas, then I could also get basically from the same, like if I have it, for example, serialized in CBOR, and I use two different schemas, I get also two representations out which have the same serialization, but from my perspective then are different.
Yeah, but the problem with this is that once you read one object, so let's say you get two IPLD schema objects, once you read one of them, before you can write with the other representation, you'd have to copy it over, which is awkward, right?
So this is fairly accurate, with one interesting bit of wiggle room in that Go is a strange and fanciful language.
Right.
And if two type definitions are structurally identical, that copy actually no ops. And it turns out we use this heavily in the existing CodeGen implementation there, because that's how we switch things between being the type level representation and the representation level representation for free, because they're the same structure. And so that flip is for free.
Sure. I mean,
it would be distinctly ugly to use that with two different schemas, but it would. I'm pretty sure click.
Sure. I mean, there's always a way to hack it around. Like, there's multiple. So this code, this compiler is not just meant for Go. Like the big point here is that basically I want to have a compiler which is from the start ready to generate code in different languages and so while yes, in Go, maybe it happens to be the case that you can, mem copy or whatever, that's generally not something you want to do in like a strictly typed language. I'm sure probably you can even do it in Rust and so forth, but it's kind of like an awkward thing to do if you can code generate something that kind of allows you to be strict in the language itself. But the bigger thing here is, so let me just give you examples like why I care about the compiler having like a pipeline of stages. So for instance, when you define data types, like so the base, like the simplest objects in the compiler are just like the types of things themselves. But then when I'm building a service, for instance, like a new concept, the user defines a service in the AST, and then the compiler actually takes the AST definition and actually generates another AST, which is actually of all the types that will be necessary for the service itself. So in other words, it's feeding on itself, and then goes off and generates all these things because they already have like down the pipeline they can co-generate and so forth. So the point is that the compiler has a bunch of stages, and you can sort of intercept. You can work in any one of them. So you start from ASTs, and you can define any object there. Then these ASTs are processed, and all the linking is resolved. And at this stage, where all the objects are defined and the links resolved, you can then do whatever manipulations you want if you want to like generate new objects and so forth. And then once you're done with this, then you can push off the generation plans, which are basically descriptions of all the objects that you want to do, to the code generation, which is a completely separate step, which is dumb. It just takes plans, but now these plans are hyperlinked with and they all have assigned names in the target language, Go or otherwise. But it makes it easy to implement complex things if you just like have clean accounting between all the stages and so forth. And the lack of this is the reason why bind node has to resort to reflection, basically. So it seems like it's a lot of work to escape.
Okay, hang on. Bind node resorts to reflection because that's useful and people like not having code gen. For what it's worth, I also completely buy and believe you that the way that I wrote the Go code gen for stuff is terrible and unmaintainable, and I regret almost every architectural choice in it. So your arguments in favor of making a code generator pipeline, I'm so excited that you're doing that. but don't throw things that use reflection under the bus entirely either.
The reason so this I guess is like a philosophy thing, because my impression from talking to a lot of you guys was that we really care about performance, and so
it's both, right? But it's situational. Like there are some places where the performance has been like super critical, and code gen, yes, and allocation minimization, oh my god, is it worth it? And there are other places where somebody wants to build a hello world, and if we ask them to use a code generator pipeline at all,
yes, but sure, but that's
too much.
So I find this not to be a good excuse, because
that's what users do, man.
We have we still have two people with hands and only 4 minutes left. So just so Adine was first, I think, if I recall correctly.
Yeah.
So I don't know.
Sorry for taking so long.
That's all right. So yeah, I think my take on like some of the reason for differences here is one of the snazzy things that I think is largely doable with big parts of the IPLD stack, whether it's the codecs or the schemas, is the ability to represent like existing stuff in the way that your target language wants to see it, right? Which is why like, oh, okay, I have the data, I tell you how it was represented so you can properly decode it into the form that I'd like to see it. Which is a little different than like building a thing that is meant for protocols, in the sense that I don't think it's like a goal of Edelweiss to be able to like describe, you know, the BitTorrent data transfer protocol within that framework, right? It's like trying to describe, when we build new protocols, How can we build them in these ways that leverage a lot of the IPLD tooling to do interesting things? And that difference in mindset, where I'm not trying to be backwards compatible with everything. I'm trying with existing stuff. I'm trying to build other things. Sort of both it narrows your scope and expands some of the things that you can do instead. And so like, I feel like this is sort of like a decoupling thing between like, I need a compiler framework because like the way that we're doing code gen with, you know, the GenGo stuff is like no fun, which is separate from like the IPLD schema syntax does not let me describe all the things I want to describe or the way I want to describe them. And in this case, what's like being described as the element that's trying to be filled in is like sort of the gRPC version of like protobufs, except instead of, it's not clear that you would want to make those exactly the same syntax as each other, because, you know, protobufs are trying to describe exactly, they're like, I'm building a new thing, here's my protobuf, right? And so they're like, okay, when I want to build a new protocol, here's my protocol with those protobufs. Whereas IPLD schema is like, I want to represent existing data in a useful way to me, which may not mesh exactly with the protocol business, which is why I think it's slightly different. That's kind of my take on what's going on here, if that is helpful for people.
Sure.
I'd like to go to the second hand, Daniel.
Yes, Daniel.
Yeah, I'll be very brief. Just to expand a bit on what Eric said about reflection, I don't really have a horse in any race, and I don't think it's even a race because they're like apples and oranges comparing, for example, Binode with Edelweiss, because Binode is a much smaller project or package, if you want to call it that. But also, and I understand that Edelweiss as a compiler is targeting multiple languages, but at least talking about Go itself, code generation is fine for some things, but my take is that for things like protobuf or schemas, it's not the best fit, because then you end up being at the mercy of the code generation and the types essentially get handed to you. So I find that that's not the best workflow, at least for Go. And I think the reflection can be made to be faster than most people think. So that's the reasoning behind the API there.
So let me answer this because I know we don't have time. So the big overarching sort of mission behind Edelweiss is the following. You want to have a type system that is truly language agnostic and can basically, like I alluded earlier, basically it has to fit every possible language, and it has to have lambdas. And actually, I will go something that's actually counter what Dean is saying. I actually do have as an objective to be able to take any pre-existing protocol, no matter what, doesn't even have to be IPLD data model, and to describe it in this universal type system. The reason is fairly obvious, right? So our goal is to connect blockchains from all kinds of programming languages and companies and so forth. And when you're trying to truly be language agnostic, there is an intellectual question, which is, I'm gonna take protocols from all kinds of places, but the only way I can manage so many different protocols is to have like a type system that sits on top that is simple enough but expressive enough to talk about everything. And so IPLD schema was close to this, but it's not close enough. In particular, it's missing unions and singletons, and also like a whole range of sort of primitive types that have to be there. And so the point is that this is my goal, is to have like a lingua franca for protocols. And because this is not like a one-off where we're going to make the type system and it's going to be frozen, there's going to be new primitives, not new composite types ideally, but like lots of other little things. So my point is that I need to have a framework for a truly language agnostic type system for protocols that can handle any pre-existing protocol, and it sets a good standard for writing future ones. So Go is of zero concern here. And so in general, when you want to have a lingua franca like this, you have to build a compiler, because the fact that you can happen to be able to do something in Go with reflection is completely not helpful if you're shooting for the stars, so to speak. Does that make sense? It's the language is like the highlight here, not. And then, of course, the implication is if you're going to have a language that sits between all programming languages, of course, it has to code generate. It's not an option to have to use the varying reflection systems of the languages that are being targeted, which is Go and Rust and Julia and Python at minimum. So, and I'm also sort of like, you know, the problem is that when one puts a lot of work in making something work in Go, that's great. It helps in no way for moving on to other programming languages. And you know, so anyway, so that's the answer. It's the language design and the type system that has to absorb everything. And so that's why Go is not like a guiding sort of design thing in the.
Okay. Yep. Thanks. All right. So we hit the hour. So thanks everyone for attending, and see you all again next week. And yeah, perhaps we can even discuss it there again if anyone's interested. All right. So goodbye, everyone, and see you all in 2 weeks. Bye.